So when we look at this problem, we want to solve for k. What is the first thing that we need to do? We'll need to combine like terms. So we'll drop down the other two, the minus 12 and the 3. When we combine minus 2, minus 3, what does that make? Negative 5. I want to get k by itself. So what do I need to move next? The 3. How do I move that positive 3? Subtract 3 on both sides. Minus 12 minus 3 is negative 15. Drop down that negative 5k. My next step is to divide by negative 5. And k equals 3. I don't care if k is on the right side. If you want to flip it, you sure can, but you do not need to. The next two are asking for you to correct the error. On these types of problems, I would solve it myself and then figure out what they did wrong. So what is the first step we want to do to solve for x? Distribute. So 5 times 3x is 15x. 5 times negative 20, negative 100. So we're going to justify, we're going to say that this was which property? Distributive. Is this property of equality? It is not. My next step is to close. Add 100. It's okay. It's Monday. So that is the addition property of the equality. What is minus 10 plus 100? 90. So my next step would be to divide by 5. Good. Which is the division property of the equality. What is 90? Ooh, it's 15.
Yeah, I was going to say.
Yeah. Sorry, it's a 15. That's why I'll give bonus points if you find the errors and tell me them before I get all the way down there. 90 divided by 15 is 6. And every time you circle your answer or box your answer, what property is this? Substitution. Because I could substitute 6 in for every x. And it would remain an equation. It would remain equal. So now we're going to look at theirs and figure out what they did wrong because we did it right. So the first step, they distributed, right? We distributed. Do our lines look the same? No. So what did they do? Yeah, they didn't do. So we're just going to correct it. 5 times negative 20 should have been negative 100. You can always check to see if they did more wrong. Then they added 20, okay, which would have been correct because minus plus. Then they divided, which would have been correct. Then they had the substitution property. So everything else was correct. They just made the mistake in the first step. The second question, we're going to do the same thing. We're going to solve it on our own and then compare it to see what they did wrong. There are not enough boxes for this one. It's so sorry. What are we going to do first? Distribute. 4 times 5x is 20x. 4 times negative 9, negative 36. Negative 2 times x, negative 2x. And then negative 2 times positive 7, negative 14. So again, this is your distributive property. I always move the smaller x. What is the smaller x here? The negative 2x. So What am I going to do with that? Add it. Both sides, which is the addition property of equality. 20 plus x is 22x. Drop down that negative 36. Drop down that negative 14. My next step, add 36, which again is the addition property of equality. So 22x equals minus 14 plus 36 is 22. So my next step, divide both sides by that 22, which is the division property of equality. X equals 1, which is the substitution property of equality. So now we're going to compare. The other side has a lot wrong with it. I'm just going to tell you that right now. So the first thing we can compare, did they distribute correctly? Do they have what we have? Yes, they do. Then what did they do? Well, pause. They didn't write the distributive property. Yeah, sorry. So they forgot to write distributive property. Then they added 2x on both sides and wrote that they used the subtraction property of equality. Is that correct? No. So just fix it and say add. They did the addition property of equality, which is what we did, you know. And then again, our lines match. We've got 22x minus 36 equals negative 14. We have the same thing. Then what did they do? They subtracted 36 and we added 36. So in order to cancel out 36, you have to do the opposite action, which would be addition. Bless myself. So they should have added 36. And then that would fix everything else. From there, they used the division property, which we did. And then they used the substitution property, which would mean x equals 1. Everything else would have been fine if they had added correctly. A lot wrong. We're going to go to 2.2 notes. We're going to learn about two different types of reasoning. Before we do, you've actually heard of one. You have this on the top of 2.2. You're being asked, it says write a conjecture about the pattern. Basically a conjecture, and we'll talk about it in 2 seconds, you would describe the pattern. We're going to skip this part seeing as you haven't learned the word conjecture. But we're going to use it to draw the 10th object in the pattern, just like the directions say. So I'm going to fill in 8, 9, 10, because we know it'd be helpful to know 8 and 9 to know 10. On mine, it's not very dark, but you've got these circles, right? You could see it pretty well on yours. So, what is the outer shape going to look like no matter what? It's going to look like a triangle, because they all have triangles. But then this circle, or I call it a ball, it rotates, right? Bottom right, bottom left, top. Bottom right, bottom left, top. Bottom right, bottom left, top. So it's actually going clockwise, like around. Bottom right, bottom left, top. So when we get to number 7, it's bottom right. So where will the next ball end up in number 8? Bottom left, and then number 9, top, and then number 10, bottom right. So there's the 10th. Does anybody know a second option of what you could have done to figure out what the 10th was? I mean, yeah, you could do that. I meant like, so if it didn't look like this, you could, 7, is there another part of the pattern that looks like 7? Because patterns repeat, remember? So 1, 1 does. So if 1 looks like 7, then 2 looks like 8, and 3 looks like 9, and 4 looks like 10, right? Or you could do the same thing. Where else in the pattern does it look exactly like number 7? Number 4. So again, if this looks like 7, then this one looks like 8, this one looks like 9, this one looks like 10. So everyone see how it goes. So you could find it, since patterns repeat itself, you could try to find it earlier in the pattern. This next one, got a couple things happening. 8, 9, 10. Either way, we've got an X and a Y axis. And a couple things are going on. We've got a line. It's curved, and it opens downward, right? It's straight, it's rotating. It's straight, it's curved, it opens downward. It's straight, it opens, is this downward still? No, it opens upward like a bowl, right? Opens upward, it's straight, opens upward. So the next one would be straight. After that, it's going to be curved. It's going to open upward or downward. So this one opened downward. This one opened downward, right? This one opened upward. This one opened upward like a cup. So this one's going to open downward like that. And then last, it's going to be a straight line. So that's a 10th. Straight line. This last one, we use my cheat that I taught you in the first one. Is there a part in the pattern where number 7 has already been seen? In which one? Number 1. They look identical, right? So if this looks like number 7, this looks like number 8, this looks like number 9, this one looks like number 10. So number 10 was going to be 2 triangles and then circle, square. You what?
You just want us to write number 10.
Yeah, I mean, that's the only one it asked for. You technically didn't have to show 8, 9, and 10. All right, so we're going to talk about 2 terms. First one is the word conjecture. A conjecture is an unproven statement based on observations. You actually use conjectures all the time about other people. It is called being nosy or being observant. So what are things that we observe? Let's see. Y'all don't do anything bad. I mean, so like some things that you see, I have some students who don't come on test days on accident. So my conjecture would be we have a test next week, so they're not going to be here. That's a conjecture. Or who's usually the first one in here? Every day, Jonathan is the first one to come into this room, so tomorrow he'll be the first one to come into this room. A conjecture is an assumption based on previous behavior. Okay, you do them all the time. Your parents probably have expectations of you, so you know what happens. If I don't do my homework, my mom will, sure, thank you. She'll take away something. That is a conjecture. Okay, based on an observation, you make a statement. My mom's going to kill me. I didn't do well in this quiz. That is a conjecture. Inductive reasoning. So you're going to fill this in. Inductive reasoning, the process of looking for patterns and making conjectures. Inductive reasoning is the process of looking for patterns and making conjectures. The process of looking for patterns and making conjectures. You make observations. If you want to write this, it's an easy way. Observations, and then it's also based on behavior. So in real life, it is based on observations and behavior. So if I observe the basketball team running suicides, or they're called line drills now, I guess. If I observe that, what can I assume happened? They're in trouble. They did something. That's inductive reasoning. Based on observation, I make an assumption. So inductive is based on behavior. It's based on observations. based on patterns. You make them about your teachers too. Like Miss, what is her name? Miss Brown with Whisker Wisdom Wednesdays. So she still does this. Whisker Wisdom Wednesday. So on Wednesday, you can assume that you're going to have a Whisker Wisdom Wednesday or whatever it is. Because that's based on previous behavior. It's not foolproof because maybe she's not here on Wednesday. Or maybe she doesn't feel well. Or, there are exceptions to every rule. Okay. The 3 stages of inductive reasoning when we're looking at patterns and things. The first one is to look for a pattern. So you're going to look at examples. You can just write what's in black. You look at examples, use diagrams and tables to help discover the pattern. Number 2, you make a conjecture. So remember, conjecture is an unproven statement based on observation. And then last, you want to verify that conjecture. Use logical reasoning to verify that the conjecture is true in all cases. When you're ready to flip, you can. So we're going to use inductive reasoning to draw the next 2 shapes in the picture pattern. It shouldn't have a dot. Like yours has a dot, it should not have a dot. Just throwing it out there. If you want to put an X over it or something. All we're looking at is we've got a square and then a diamond and then a square. So the next one would be a diamond and then a square because it says draw the next 2. This shape is actually rotating. So here's what I mean by that. If you look at my screen, this is not a square, but it's close enough, right? It's rotating about 90 degrees. So you'll see where the next 2 arcs should be, and then rotate again. So it's like tumbling, if you will. Number 9, draw the next 2 shapes. So the outer shape is a square. The first figure is just 1 square. The second one is split into 2. Third one is split into 4. Then split into 8. So ours will be split into 16. So here's how I draw it. Just that it's just easy. If you cross into 4 big squares, you can make 3 lines, and that makes 4 and 4. Do the same thing over here, and that makes 4 and 4 more. And 4 boxes of 4 make 16. The next one, ain't nobody got time, because how many boxes are we supposed to have in the next one? We'd have 32. So we're going to just say 32 boxes, because sincerely, nobody has time for that. Hard pass. Number 10. Number 10. We have an X and Y axis, so we know the next 2 will both have an X and Y axis. The only thing that's changing is the point. The point is going counterclockwise. It's actually going in order, because this is called quadrant 1, like in algebra. Quadrant 1, this one's called quadrant 2, quadrant 3, and quadrant 4. So in each one, it's in quadrant 1, then moves to quadrant 2, then moves to quadrant 3. So then we'll have a point in quadrant 4. Then you need to observe the numbers. We have 3, 1. Then they flip to negative 1, positive 3. Then they flip again to negative 3, negative 1. So guess what? They're going to flip again, right? Yeah, so 1. And then negative 3 because, to the right would be the positive 1, and then down 3 would be that negative. So remember the quadrants. That's why this one is positive, positive. This one is negative, positive. This one is negative, negative. And this one will be positive, negative. So the last one will be in the first quadrant. And then my numbers will flip again. So 3, 1, which really means we start all over. When you're ready, we flip. We're almost done, believe it or not. You learn about deductive reasoning now. So inductive, you use previous examples and patterns to form a conjecture. So this is perfect, your class. Some of you are in 10th grade, yes? So inductive reasoning would say, historically speaking, Molly is in 10th grade and Alana is in 9th grade. Right, I get that. So realistically, which one should be older? Molly should be older because she's in 10th grade. That is based on a pattern. Okay, because 10th graders are usually older than 9th graders. So that is inductive reasoning. Okay. So this one says it's the same thing but with different names. Andrea knows that Rob is a sophomore and Todd is a junior. So we really know that juniors should be older, so Todd should be older. Deductive reasoning, you're going to fill in the blank. You just need to fill in that it uses facts, definitions, and accepted properties. Uses facts, definitions, and accepted properties. Facts, definitions, and accepted properties. The properties part really applies to geometry. It's got laws, things like that. So deductive reasoning uses facts. So Molly, you were born in what year?
2001.
What year were you born in?
2005.
What month were you born in?
February.
And you were born in?
November.
Okay. So because we know their birthdays, we know that Molly is 9 months older than 9 months. 211, that's 9. I'm not wrong. So we know because of their birthdays that she is older than Alana. So that would be a fact. So that Molly is older than Alana because of their birthdays. So this one's going to give a different example. This one says, we could do it this way. We know Molly is February of 05. Is anybody younger than her? November of 05? You're younger? Okay, so Alana is November of 05, and Kadriana with one N is May of 06. So here's what deductive reasoning says. I know that Molly is older than Alana. We agree? Alana is older than Kadriana because their birthdays. So then that means Molly is older than Kadriana. That's deductive reasoning. Because I know their birthdays, I can make assumptions. Not assumptions. I can draw conclusions. So these two, we're going to decide if they're inductive or deductive, and then we're going to explain our reasoning. This letter A is really hard for students to picture because y'all are old. You're old, right? Each time Monica kicks a ball up in the air, it returns to the ground. So the next time Monica kicks a ball up in the air, it will return to the ground. Is she assuming that the next time she kicks it up, it will come down because she's watching a pattern or because she knows about gravity? Which one is it more so phrased towards? A pattern. So this is inductive reasoning. Inductive reasoning, because I can spell, reasoning, she's observing a pattern. Make sure if it says explain your reasoning, you do. She's observing a pattern. You don't know how old she is. My daughter is 3. She does not know the law of gravity. If it said instead, Monica knows because of gravity, what goes up comes down. She knows when she kicks this ball, it will come down. That would be based off of a law. Right now, she's just observing when she kicks it, it comes down. So the next time she kicks it, it will come back down. Letter B, it says all reptiles are cold-blooded. Is this an observation or is this a fact? It's a fact. Parrots are not cold-blooded. Is this an observation or a fact? Fact again. So Sue's pet parrot is not a reptile. So this is deductive because it's based on facts. This next section, I just want you to write inductive or deductive. You can write IND or DED. Inductive, remember, is based off patterns of behavior, and deductive based off of rules, laws, or facts. Number 1, a chemistry experiment produces the same result 20 times. You conclude that it will always produce the same result. That's inductive because you're observing a pattern. You see that it produces the same result, so that you make a conclusion based on that. Number 2, Tim is Veronica's cousin. Is this a pattern or a fact? It's a fact. Since David is Veronica's twin brother, so they're siblings, Tim is also David's cousin. So what do we think? Is deductive. Because those are facts. Siblings, twin siblings, will have the same cousins no matter what. The school librarian notices that many students are requesting books about different countries in Africa. The librarian concludes that one of the social studies classes must be studying about Africa. Inductive. Number 4, Julie notices that each term of the sequence, 1, 3, 9, 27, is found by multiplying the previous term by 3. She concludes that the next two terms are 81 and 243. It's inductive. I don't have room. I'm just going to write an I over here. It's inductive. She is looking at a pattern. So, especially when you see the word notices, that's an observation. Given the sequence 19, 23, 27, and 31, you conclude the next term will be 35. It's still inductive. It's still a pattern. You're adding 4. Number 6, we know that all men are mortal. What does mortal mean?
They die.
You can die, yeah. So we know that all men are mortal. Since John is a man, John is mortal. So what do we think? Deductive, because they're facts. And then all of the people that you met in town are very strange. You conclude that everyone in town is very strange. Inductive, because you're observing.